Okay, so it says Ashton has a 1 through 6 number cube and spinner like the ones shown below, which shows all positive combination if Ashton wants an even number on the die and a green or purple on the spinner. So what are the even numbers for the cube?
2, 4, 6.
So it's 2, 4, and 6. And then we want either purple or green, right? So that's how you would see it as a tree diagram, but they're showing you a list. So if you look at letter A, why is that one incorrect?
Because it has all the numbers.
Yeah, it has all the numbers, so they didn't ask for all the numbers, they only asked for the even numbers. How about B? Why is that one incorrect?
Because it has 2 times.
Well, it's supposed to have 2 times.
Oh, it has red.
It has red, so that's wrong. How about C? It has 2, 4, 6. It has purple and green.
Yeah.
So why is it wrong? Because the correct answer is D, but why is C wrong?
Because it's wrong.
Because it wants to be.
Oh, that's a very good excuse, because it wants to be wrong. No, if you look, 2, you have green, but then the next 2, you have green again. That's why it's incorrect. Be careful with those, because that's what they'll do to trick you. So that's why that one's a wrong answer. Okay, so what we're doing today, we're starting with compound event. Okay, I'll let you write this down a little bit, but I want you to pay attention. Now, on when we started probability, I asked you to look at a cup, and we had different colored tiles. So say, for instance, in that cup, I had 1 blue tile, 2 yellow tiles, 2 green tiles, and 3 red tiles. Okay, so we have a total of 8 tiles. Now, if I asked you what would be the probability of getting a blue tile and then getting a yellow tile, what would be the probability of getting a blue tile?
1 out of 8.
1 out of 8. And if I put it back, then I go ahead and do the yellow tiles, what would it be?
It would be 2 8.
2 out of 8. Okay, now, what if I told you I want to do the same thing? I want to get a blue tile and a yellow tile. So if I take out a blue tile, the probability of getting a blue tile will be what? 1 out of 8, right? It's still 1 out of 8. But I don't put it back in the cup. So what happens? So is that going to be still, for yellow, 2 out of 8? No, it's going to be what? It's still 2. You still have 2 yellow tiles. But now you have how many total tiles? If I don't put the blue back in?
Oh, 7.
7. So when you're doing this, that's why it's called a compound event, because you're doing one thing, one event, and then another one. So you're combining those events. But we have an event where you replace the item, and then we have another event that you do not replace the item. And that's what we're going to be looking at today. So what I need you to do is I need you to fold the paper, your paper that you picked up, fold it as a hot dog. Make sure that compound event shows. That's what it shows here. And then you're going to draw lines and then write in, are the events independent or dependent? Are the events independent events? And then dependent events. So make sure you write this down, and then we'll go ahead and write in the notes. Okay, are the events independent or dependent? That's the title of this section. Okay, so what we're going to do, we're going to fill in the blanks and then determine if an event is independent or dependent. So here, the definition is determine if the event, and there's a typo, so go ahead and cross the first. So determine if the events of the first probability affects the second probability. So if the first probability does not affect the second probability, then it's going to be independent. If it does, then it's dependent. So if yes, it is dependent. If no, it's independent. So here are some examples. So determine if the two events are independent or dependent. So flipping a coin, drawing a marble. Are they independent events or dependent events? So flipping the coin, if you flip the coin, will it affect drawing a marble? No, it's independent, so that's why we're going to put independent.
Oh, no.
I made it fit.
You lost me right there.
Oh, the writing? I squished it in. Okay. The second one, picking a card, not replacing it, and then drawing another card. So is that independent or dependent? Dependent. Because you did not replace it, that means the total of cards is going to go down. Tossing a coin 2 times. Independent, because even though it's 2 times, that doesn't depend. You can't remove one of the outcomes, right? For the coin. Can you remove an outcome in a number cube? No. Can you remove the outcome of the spinner? If you have a spinner, can you remove one item? No. Can you remove an outcome of a deck of cards?
Yes.
Yes. Can you remove the outcome of a bag of marbles?
Yes.
Yes. So do we see what's independent, dependent?
Maybe.
Yes? Okay. So basically, a dependent means that the total is going to change. That's all it means. Okay, independent events means that 2 events are independent if the outcome of the first does not affect the outcome of the second, so that the probability is not changed. So here's an example. You have a bag of marbles. You have 1 black marble, 2 white marbles, and 3 striped marbles. So this is what they're asking. What is the probability of drawing a white marble the first time, replacing it, and then drawing a white marble the second time? So this is the key word, guys. When they say replacing it, that means that's going to be independent. So total does not change. Okay, so let's go ahead and put probability of drawing a white marble. Then another white marble. So what would be the probability of drawing a white marble? How many white marbles do we have? 2, right? So then the probability is going to be 2 out of 6 for that white marble. Okay, how about the next white marble? I'm putting the white marble back, so what would be the probability of that? 2 out of 6. Okay, so in order for us to find this compound event, so it's probability that there's 2 types of probability, or 2 probabilities, we're going to multiply them to find out what it is. So 2 times 2 is 4. 6 times 6 is 36. And if we simplify it, this becomes 1/9. Now, can I simplify it first and then multiply it? Yeah, we could do that. We could simplify it first, then multiply it. So I know 2/6 is 1/3, and 2/6 is also 1/3. So 1 times 1 is 1, and 3 times 3 is 9. So we could simplify it before, simplify it after. It's up to you how you want to do it. Okay? Any questions on that? Okay. So what I want you to do is try it out. You try it out and see what you get. And I'll come around to see if you're doing it correctly. Okay, so in case you didn't do this, or you're still working on it, it should have been 1 out of 6 times 2 out of 6. That's going to give you 2 out of 36. When you simplify it, it's going to be 1 out of 18. Okay, so these are dependent probabilities. So it says 2 events are dependent if the outcome of the first does affect the outcome of the second, so that the probability is changed. So basically when they say changed, and they mean the total is changed. Change affects. So the events are dependent if the outcome of the first does affect the outcome of the second, so that the probability is changed. Okay, so let's go ahead and look at what the example says. What is the probability of drawing a white marble the first time, not replacing it, keywords, and then drawing a white marble the second time? So because they're not replacing it, then that means the total will change. Okay, so let's go ahead and do the probability of white, then white. Okay, so if you look at the bag of marbles, there is 2 white marbles out of 6. So that's going to be the probability of the first event. Then, because we're not replacing it, I'm crossing that out. And now you need to see what's the probability of getting a white marble this time. So that's going to be 1 out of 5. 1 out of 5. So now all you have to do is multiply it. So 2 times 1 is 2. 6 times 5 is 30. You simplify it, and that gives you 115. Now remember, because we did not put that white marble back in, it changes the number of white marbles in the back, and it changes the total too. And that's why they mean it's a change. So go ahead and try this out yourself. Remember, it does say not replacing it, so your totals will gonna change. Be careful with those. So this is your assignment. Make sure first that you've turned in all your assignments this week. So Monday, Tuesday, Wednesday, you had an assignment, a classwork, became homework. If you haven't turned in any of those, I suggest you work on those, because it's kind of a makeup day, but still doing a lesson. So make sure that you are working on those first, and then you could come and get this assignment today, because that's due tomorrow. And you'll have time to do this tomorrow, so don't do it for homework, because I'm going to have you finish it tomorrow. But the rest of the assignments, if you haven't turned them in, make sure you turn those in.
Which one are you doing?